created a Geogebra file and for the Quadrea of a projective quadrangle in Universal Hyperbolic Geometry, and I'll quickly demonstrate it. Here, the setting is Universal Hyperbolic Geometry, and this is the null circle. This blue circle is the null circle in Universal Hyperbolic Geometry, and I have here a quadrangle, a projective quadrangle made up of 4 points, A1, A2, A3, and A4. And I have a point M in general position in the middle. And up here, I have 3 rows. Each row is a calculation of the quadrea of a projective quadrangle. And so the first one is from the original equation for the quadrea of a projective quadrangle. The second line is from an alternate form of that equation, and it produces the same result. And the third equation is also an alternate form of the original equation and produces the same result. If I move the quadrangle points around, then the calculation for the quadrea of the projective quadrangle changes. You see I get, and all 3 equations produce the same result. Okay, and what I have here is I'm also able to move this point M around, and you see that it doesn't change the value of the quadrea of a projective quadrangle. And this third calculation uses this triangulation of the quadrangle. Now I can toggle. Click this checkbox here to show and not show the triangulation, and I can move this point M around, and I can bring it to the boundary or beyond the boundary. That's fine. And what I'm interested in is see what happens when the point M is on the boundary. So to put the point M on the boundary, I'm going to intersect 2 lines. I have this checkbox here to show intersect line, and that brings up this line with 2 control points which I can move around. And up here I have a toggle intersect line text. If you just click on that text, it'll change it to a new value like 1, 2, 3, 4, and 0. So if I set it to 1, then that when I move this line around, it'll move this point to line 1. So here I've moved it, the control point, and M is on line 1, and its amplitude, or sorry, its value of the quadrea of the projective quadrangle blew up because when this point is on the line, there's a pole in the formula, but the other 2 formulas remain the same. And what I can do is I'll move the point up, and you see it. And I'm going to put it on line 2 now by toggling the line number here. So it's now 2, and when I move this point, that point M is on line 2, and the value you see goes to infinity because the formula has a pole in the, and when the point is on the line. Okay, so that's what I wanted to demonstrate. I'll put this back to line 0, and I'm going to turn off the intersect line and move the point M by clicking on it and dragging it. And you see that the 3 values for the quadrea of a projective quadrangle from the alternate formulas of it are all equal again. And if I toggle the show triangulation, I get the triangulation of the projective quadrangle. Okay, that's a quick demonstration of what the Geogebra demo can do for you. I'll attach the file to the description. Thank you.